All right, our next lesson in similarity will have to do with using similar polygons. So we're going to explore what it's like to be, what makes polygons similar, and some properties of that. All right, let's go ahead and start with vocabulary. Two vocab, things that define similar polygons, and scale factor between two similar polygons. Go ahead and pause the video right now, or you can go ahead and look at page 372 in your book and figure out what these two things are. So I guess I'll give you a minute. Go ahead and pause and fill these out. All right, now that we've gone ahead and defined what similar polygons are, let's take a look at what two similar polygons might look like. Two polygons are similar. This is different than congruency in the sense that congruency meant that two shapes were the exact same shape and the exact same size. So basically, exact clones of each other. With similarity, you're going to find that the two shapes will be exactly the same as far as their shape is concerned. However, they will be different sizes. This will be similar to what we did with dilations with our transformations unit. So these two triangles will be an example of similar polygons. You see they're both triangles. They look very, very similar as far as dimensions. Just one of them is going to be XYZ is smaller than triangle ABC. Now, to show the two triangles are similar, we have what's called a similarity statement. Similarity statement works very similar to how the congruent statements worked. As we have, in this case, we have two triangles that are similar. Triangle ABC is similar to triangle XYZ. This symbol, which is like a tilde, is our similar symbol. So that's how I show that one triangle is similar to another triangle. A similarity statement is going to work very closely to the congruency statement, where we're going to have corresponding parts. So we've got angles and we've got side lengths. Let's start with the angles. In similar polygons, corresponding angles are going to be congruent, just like with congruency. So in this case, so A is the first letter and X is the first letter. Therefore, angle A will be congruent to angle X. B is my second letter. Y is my second letter over here. So angle B will be congruent to angle Y. And then lastly, C is my third letter, Z is my third letter over here, so these two angles will also be congruent to each other. So as you see, all three angles from the first triangle are congruent to all three angles in the second triangle. But this is where the congruency is going to stop. We don't need to, we can look at the two shapes and realize that the AB and XY are not going to be the exact same size. XY is smaller than AB, and like we said, they're going to be the same shape, they're just going to be different sizes. So congruency, the angles are going to be congruent with similar polygons. However, the sides are not going to be congruent. The relationship between the sides are going to be what we call proportional to each other, meaning that all three sides from triangle ABC are going to have the same proportion to all three sides from XYZ. And we're going to be able to write what we call a statement of proportionality. And a statement of proportionality is just three ratios that are going to be exactly the same. For example, let's say for triangle ABC, AB was 8, BC is 10, and AC was 14. In my second triangle, XYZ, if XY was 4, YZ was 5, and XZ was 7, the ratio of all these sides to from one to the next would be, so AB over XY would be my first ratio, 8 over 4, which would reduce to 2 to 1. BC, which is 10, over YZ, which is 5, would also reduce to 2 to 1. And then AC, which is 14, over XC, which is 7, would also reduce to 2 to 1. So each one of these would have the exact same proportion, where essentially triangle XYZ is half the size of triangle ABZ, because every single one of the sides is half of the side length from triangle ABC. All right, for example, number 1, we're going to go ahead and explore some similar triangles, and just start with my similarity statement. So the similarity statement that's given to me is triangle ABC is similar to triangle DEF. Now, just like we just did, we want to go ahead and list all the pairs of congruent angles, and we don't even need the diagram for this. We can look at the similarity statement and figure out which angle goes with which angle. So first, we're going to have angle A and angle D, which are both the first letters of the similarity statements. So angle A is congruent to angle D because they are both in the first spot of my similarity statement. Angle B and angle E would also be congruent because they're both the second letters in my similarity statement. And then lastly, angle C would be congruent to angle F because they're both in the same spot as well. They're both the third letter in my similarity statement. So 3 pairs of angles congruent, and like I said, we can get all this from my similarity statement that's given to me. Now for the next piece of this, we want to start talking about the corresponding sides. We're actually going to go to number 3 first. We'll do this one first, and then we'll go back and do number 2. We want to write the statement of proportionality for these 2 triangles. Now again, we can use the similarity statement to write the statement of proportionality. So we're going to write ratios. Write 3 ratios, and all 3 ratios are going to be equal to each other. We'll start with AB. AB is the first 2 letters of my first triangle. That corresponds with DE, which is the first 2 letters of my second triangle. So AB over DE is going to be my first ratio. This is going to be equal to BC, which are the second and third letters of my similarity statement for my first triangle, over EF, which are also the second and third letters. So this is my second ratio. And my last ratio is going to be my first and third for my first triangle, which would be AC, over DF, which are the first and third letters for my second triangle. Right? So this is my statement of proportionality. AB over DE equals BC over EF equals AC over DF. Now the reason why I did this first is because number 2 wants us to check that the ratios of the corresponding side lengths are equal. This is going to be a lot easier with my statement of proportionality because all I need to do is just substitute right now. So we'll start with AB over DE. AB, according to my diagram, is 10 over DE, which is 15. That's my first ratio. Now that should be equal to BC, which is 8, over EF, which is 12, which is equal to AC, which is 12, over DF, which is 18. Now all 3 of these fractions can be reduced, so we're going to reduce each one of them. Okay, 10 over 15, we're looking for common factors. 5 goes into 10 2 times, 5 goes into 15 3 times, so that reduces to 2 over 3. 8 over 12, 4 goes into 8 2 times, and 4 goes into 12 3 times. And then lastly, 12 over 18, 6 goes into 12 2 times, 6 goes into 18 3 times. As we see, all 3 ratios reduce to 2 over 3. Okay? So this is the ratio from triangle ABC to triangle DEF. And since all 3 sides have corresponding ratios and the ratio is exactly the same, we can go ahead and verify that these 2 triangles are similar to each other. In example 2, again, we're going to go ahead and identify pairs of congruent angles. Now, we don't have triangles this time, we have quadrilaterals, but any pair of polygons can be similar to each other as long as they're the exact same shape. So both of these polygons, as long as we can show that all 4 angles from ABCD match up with all 4 angles from JKLM, and then that all 4 pairs of corresponding sides have the same ratio, then we can say that these 2 quadrilaterals are similar. So first, let's identify the pairs of congruent angles. Looking at my diagram, we've got angle A and angle J are both right angles. So there's one pair of congruent angles. Next, angle B and angle K both have one arc in there, meaning they are congruent to each other, giving me a second pair of congruent angles. Angle C and angle L both have 2 arcs in there, giving me a third pair of congruent angles. And then finally, angle D and angle M each have 3 arcs, showing me that they are congruent as well. Now, just having 4 pairs of congruent angles isn't going to be enough. We need to also verify that each pair of corresponding sides has the exact same ratio. So we can start with AB to JK. So AB to JK is going to be 8 over 14, which is going to reduce to 4 over 7. BC to KL is going to be also 8 over 14, which is going to reduce to 4 over 7. CD to LM is also going to be 8 over 14, which reduces to 4 over 7. So far, I've got 3 ratios that are all exactly the same. We need to verify my last one, so we need to do AD to JM. So AD is 12 JM is going to be 21. Looking for a common factor. 3 goes into 12 4 times. 3 goes into 21 7 times. So I get 4 to 7 as my last ratio. All 4 corresponding side lengths have the exact same ratio. Now the last thing that it wants me to do is list what we call a scale factor. Now it's important to look at, so it says find the scale factor of ABCD to JKLM. The way this is written is extremely important because this means that since ABCD is the first one that I list here, that needs to be the first number in my scale factor. And that's the way we did the proportions. Okay, so we're going from ABCD to JKLM, which is small to big. So your scale factor is going to be 4 to 7. Now you can write that like this. You can write it like a fraction. Either way works. A lot of times with scales we write it as a colon, 4:7, as 4 to 7 for the scale factor. Okay. Again, if I write 7 to 4, that's wrong because it's giving me the instructions to do ABCD to JKLM, which means the number relating to ABCD has to come first. And now, as always, if you have questions, make sure you write them down on the side and ask them next time you see you. Have a good day.